60 years ago, a small group of scientists made a quiet but audacious decision to dedicate their lives to understanding the mammals around them. Not from headlines or fanfare, but from curiosity, from fieldwork, from the patient work of researchers willing to follow animals into the unknown and walk away changed. 6 decades later, their work spans continents, shapes policy, and saves species. This is the story of the Mammal Research Institute, told through the eyes of the people who have helped shape it. Welcome to 60 Years in the Field. After 60 years of research, most people who have passed through the halls of the MRI will tell you one thing. Somewhere between the beginnings of an idea and the eventual impact of a study, there is dirt under the fingernails and days that don't end when the sun sets. This is where the MRI's work really begins. Not in boardrooms or offices, not even, most days, in a lab, but out here. In this episode, we follow the scientists who do the work few people see. The ones who trade comfort for closeness and certainty for a front row seat to something extraordinary. From elephant paths to open water, this is Forged in the Field. Our first guide into the world of fieldwork is Professor Michael Summers, a researcher whose career has taken him deep into the lives of Africa's carnivores. But before any of that, there had to be a beginning.
My honours project was on scent marking on Sunni, so that was my first thing into research, and then I was offered an MSc on warthogs, also behaviour, so most of my initial work was animal behaviour rather than ecology. After the masters, applied for a project on otters down in the Western Cape, but we worked all over the country, and that was my first experience of carnivores, and although it was difficult work, it's very rewarding to be able to do and see things that no one else has. Halfway through that, I experienced wild dogs with the famous Gus Mills in Kruger Park. We spent some mornings at a den, and that convinced me I needed to work on wild dogs. And I've sort of been working on wild dogs since in various places and projects, and many other carnivores, from hyenas to leopards to cheetahs to genets to mongooses and a few other things in between. So I worked on aphids and spiders on Marion Island, of all things.
Fieldwork really announces itself as something glamorous. Prof. Summers has weathered enough of it to know exactly what it costs and exactly what it can give back.
The main thing was always getting up early. If you're working on otters, they're nocturnal mostly, and then wild dogs, they hunt at first light, so you've got to be out before then. I think after a while, after you spend a few hundred hours with a species, you get it's a bit of woo-ah, but sort of a feeling for them, and you start being able to predict what they're going to do, and you sort of understand why they're doing it. And if you're sitting just with the data of positions, you don't understand why they're doing it. And I often get that when I'm reviewing papers. I think, yeah, but you can see they haven't spent time in the field because they're not understanding their data properly. What you learn in the field is much more than you're going to sitting behind your desk. If you want to read papers, you can still read them in the field. But, yeah.
Professor Summers' influence extends well beyond his own research, carried forward, in many instances, by the students who've passed through his supervision. One of them followed that path all the way from Europe to Southern Africa.
I wasn't really looking for any species in particular. I just wanted to, do some field work, gain some experience. The brown hyena research project was the only project that fitted all these requirements, and that could also take me at the time I wanted to, so I kind of ended up here a bit like that without really choosing hyenas. I really enjoyed it, and the year after that I came back to do my master's, and then I spent a year in Kenya working on hyenas also, and then I came back in Namibia and I did my PhD. Now I'm still here and I'm running the project on site. My main study area is Baker's Bay. I spend most of my time just basically sitting on a rock at the seal colony from sunrise to sunset, and just recording all hyena activity there. What's very unique about this place is that there's what we call a temporal partitioning. So brown hyenas are usually nocturnal. So we've got 2 resident clans at the seal colony that are nocturnal and visit the seals at night. But then we also have a lot of other hyenas coming from clans further inland, And actually, most of these hyena visit the seal colony during the day. And that's a way for them, we think, to avoid too much competition with the resident hyenas because they're very territorial. So Baker's Bay is very unique because you can just sit there during the day and you can see like 5-6 different hyenas during daytime coming to hunt seals. And actually my peak activity was around midday. That's really, something that you don't see anywhere else. I obviously have camera traps all over the place. So that's also part of my work, to just drive around, go to the camera traps, make sure they're working properly. I'm also coloring hyenas and fitting them with GPS collars. When the hyenas are colored, I'm constantly checking the data, where they are, and every time they don't move much or I get a mortality signal, jump in the car and drive a few hours to try to find out what's going on, what's happening, if they're dead, to try to find them quickly, to do necropsies and try to understand the cause of death and all these things. So it's quite wide and it changes all the time, which is also something I really enjoy, that you never know what will happen out there.
No 2 days in the field look the same. It's that very unpredictability that has put Marie in the right place at the right time to witness something that had never been recorded before.
I had this one hyena who specialized in hunting adult seals. It's never been recorded before because the hyenas here have specialized to hunt like seal pups, but seal pups are super easy prey. But this one female, she actually specialized in hunting these adult seals, and it was really impressive because the adult seals are actually heavier than an adult brown hyena. The whole story of this hyena, it's something that you can only really see the evolution by actually watching it. Because a year and a half before she started hunting adult seals, it was the first time I saw her come to the seal colony, and she was actually afraid of seals. Probably because she had just discovered the seal colony, she didn't really know how to be around the seals, and every time the seals were moving, she was running away, she was very skittish. And quite quickly, she became a good hunter of the seal pups. As the pups get older, they get more difficult to hunt, and sometimes you don't have that many seal pups available at the seal colony, and somehow she just figured out a way to hunt adult seals. Later, I fitted her with a GPS collar to see where she came from, but just with the GPS collar, you would not be able to know all these things. And that's also the case for all the social behaviors. If you don't actually sit there, you don't see how they interact with each other. I've seen mating, I've seen fighting, I've seen hyenas like feeding together. Basically, the combination between the data you get from the collars, from the camera traps, and from your behavioral observations, they all complement each other. And then it really helps you get a bigger picture. But even with all of that, I still have so many questions that are still waiting to be answered. And I just wish I could just follow them 24/7 to understand, but unfortunately I can't do that.
We can't follow our study species around the clock, but every dropping left behind has its own story to tell. A record of what an animal has been through long after it's moved on. Getting a usable sample is never as simple as just finding one. This is what that process actually looks like on the ground.
We've just seen some giraffes, so there's been 2 adult females here with one of the new babies and one of the new baby boys. They dropped a couple of samples, and this is one of the most challenging things working, especially in the wet season. You guys can see the environment right now is incredibly thick, so actually finding the sample is an absolute nightmare. Look with me here, you'll see how difficult it can be to find them. We've already got dung beetles sort of converging, but you'd have to open up a whole section like this of bush. But they kind of spread in the area here, so you'll see there's one, some have landed here, some have landed a bit further apart. I saw a couple bounce off her back legs. So ideally you actually want to find a good landmark that you can zone in on and then kind of narrow down where the sample is from there. During the dry season it's a lot easier, obviously. We don't have as much greenery around, and when you do collect samples we try and do things like make sure that there aren't any dung beetles inside the sample you've collected, just to try and make sure that we're disturbing the environment as little as possible. Gloves, really important, but the gloves are there to protect us, but probably most researchers would say that the most important thing is that we're actually protecting the sample, so you don't want any cross-contamination. So the gloves, as much as they're protection for us, it's also protection for the sample at the end of the day. Once we collect the samples, I've got a couple saved up here, straight into the little sample container. We want these samples as absolutely fresh as possible because we're measuring the stress response of the animal, and the hormone that we're measuring is a glucocorticoid hormone. We don't measure the actual steroid hormone that you would find in the blood, for example, and that's going to give you a quick snapshot. So if you are actually measuring an animal that you've captured, you're not measuring their response to the environment as much as you're measuring their response to being captured by you and actually, your handling of the animal. So when we collect these fecal samples, there has been a process that the steroids have gone through where they've been metabolized in the gut and the liver prior to being excreted. And when they come out excreted, there's obviously a lot of bacteria present with everything else in the fecal matter. So these metabolites that we measure, or the signal that we get from them, changes over time as bacterial alteration occurs. So what we want to do is get the sample as fresh as possible, so we know when the sample was dropped, and then get it into a freezer at minus 20 degrees Celsius. Then we get these bad boys back to the lab, we get them into a freeze dryer, and we'll remove all moisture from that sample. Once we've done that, the resultant powder that we get from this can be stable for years. So you can store these samples in a lab, and years later, if you come across another question and you've labeled your sample well, for example, we know this is a known individual. This is a female called Jill, who's on the property here. We know a bit more about her life history, of how many babies she's had, what time of year the sample was collected. So the more information you have, the more you can kind of gather out of the sample. And somebody could come along years from now with perhaps another question. We're looking at tourism and the impact of tourism on stress. But somebody could come years from now and want to examine a different question. They're looking at female giraffe across South Africa. This sample at the lab in its powder form will be stable for years to come. So we actually have a really good library to draw on for future studies as well. So what we try and do is maximize absolutely everything we get from each and every sample that we're collecting out in the field, because it is time consuming. We have funding constraints and all those kind of things we have to deal with. So you want to maximize each and every sampling opportunity you get out here in the field.
Every sampling event takes time, effort, and often a fair amount of luck, which is why getting the most out of each sample and every data point it can possibly yield matters so much. For one MSc student, that same mentality has become the foundation of a project built on a lifelong fascination.
Ever since I was a little cub, I've always loved everything related to elephants. Elephants have always been my passion. They are my reason for being. I want to do everything that I can to help elephants and help their conservation and their research. And this project, dealing with potential conflict situations, I feel it's the perfect opportunity to do so, because it's so easy to make all kinds of assumptions. The moment you hear wildlife, domestic livestock interactions, you immediately think, oh, conflict or fatalities or so on. And that's really not always the case, especially in this case.
Taser's research sits at a potential friction point between elephants and the livestock that share their landscape. For him, it's less a job than a chance to spend his days beside the animal he's loved his whole life.
I live for the field, and every day from around 4 until 8 at night, out driving in the bush and searching for elephants, cattle and zebra, hoping they would leave me a sample that I could collect in order to use for the research. Visibility was quite an issue in a lot of cases, so I had to leave the car most times and track the animals on foot, and that's just one of my favorite things to do. The elephants also pushed over multiple trees into the road, and then I had to jump in and chop it up and try and get the logs out of the way and go on my merry way. And it was such an amazing experience to be able to be where they were just at, and learning the tracking skills that I picked up. It was phenomenal. I really enjoyed that.
Most days fieldwork is measured in samples and spreadsheets, but every so often it hands you a moment that matters in a very different way.
I was walking towards this water hole, hoping to find something. The road was quite abandoned, so I thought, okay, so if there's not a lot of people coming here, chances are there might be a lot of animal activity. And I sadly couldn't use the vehicle as I was walking. And it's not just like walking and making noise and stuff. You have to be extremely quiet. It doesn't matter how quiet you are, the animals are always more quiet. And I noticed that when all of a sudden, out of nowhere, out of the thickets, 2 massive elephant bulls walked out in front of me. Okay, so now I saw where this elephant had stood. So I wanted to see, okay, can I, how well are my tracking skills improving on the job, And then I tried to see where he was going from where he was standing. As I was doing that, I found something in his direct line of path. If he hadn't seen me and changed his direction, he would have walked straight into a poacher's snare. And I was able to remove that snare. And for me, just in that small way, just being able to contribute in something like that, that's always been a dream of mine.
Not every fieldwork expedition offers a moment like that. Some simply demand that you keep showing up, wherever the days may take you. Lorien van Dijk's research follows black-backed jackal, a species that has led her across a variety of habitat types.
Every site has its own challenges. Like when you're working in something like the Kalahari, it's very sandy. Yes, we worked in the green Kalahari, but it was sand. So from a vehicle perspective, that's rather challenging. But I suppose when looking for samples, it's a bit easier because you don't have to deal with as much vegetation. Whereas where I worked in like more of a grassland setting, man, it's hard finding poops in the little grassies next to the road.
Jackal don't stay put, and neither does the ground she has to cover to find them.
In reserves where there might be dangerous game, working on foot unguided is not an option, which is where I was really privileged to have a study site where jackal are kind of the apex predator. They are the apex predator there. So I was possible to work on foot. If I wouldn't have been able to work on foot, I wouldn't have been able to complete my fieldwork there. So I needed samples where I was able to tell the sex of the animal it came from. And I had a really cool opportunity to actually have an observed defecation. So I saw a jackal poop, which in the end is helping me validate the method I'm using, because I have that free-ranging sample, which I wouldn't have had if I didn't actually see the jackal and spend time with my species in the field.
Some days don't go to plan, and on those days, getting through isn't about technique, it's about mindset.
Don't give up is the best way I can put it. Some days are great. You find what you're looking for, the terrain's relatively easily accessible, don't have many other factors like making your fieldwork any harder than it's supposed to be. And then other days are really hard, like days where it's just pouring with rain from before sunrise to after sunset. Can't use any samples during that day because the water just washes away all the hormone metabolites and it degrades the DNA. Can't use any of those samples, even if you find them. But yeah, with enough coffee and sheer willpower, I powered through.
And then, every so often, persistence and patience is rewarded. Lorien shares an encounter that stayed with her long after her time in the field came to an end.
The pups. I had my coffee with them every morning and I had like my late afternoon coffee with them. So I would pack a little traveling flask of coffee to go with me. At like 6 in the morning when the sun was peeking its head out from behind the koppie, I would go sit flat on the ground and sit and watch. And then they would come out of the tall grass where they hid away. I assume they have a den somewhere close by. The adults would just quickly run across the road and pretend I didn't see them. And then the 3 pups would come out and play. There was this big log which they like to chew on, and then they'd chase each other or bite each other's ear, do what little doggies do, essentially. Not doggies, jackal. So then they'd play around, and over time they grew a little bit curious of me, and they started to close that gap just a little bit, but I could see them knowing I was there. And it was so much fun seeing how differently they acted towards me sitting there having my coffee versus me walking past versus me driving past, which was a fun little side hustle, if you want to say it like that, which was really special to me. Because it was only me in the research center. I didn't have any human contact for days on end, so it was very comforting to go and spend some time with the baby jackal. Well, not babies, but the little ones.
From dust to salt spray, the MRI's research extends past the savannah and out into the open water, where Christopher Wilkinson spends his working life among some of the largest animals on the planet.
The whales come to South Africa in our winter. Often it's just me that'll go out with a whole bunch of students, which involves a lot of quick training, how to put the boat in on the slipway, how to drive a bucky. Then it's out on the water for 6 to 8 hours, long day, a lot of sun, a lot of wind, and then deciding which whales to sample. Are they good whales? Are they bad whales?
Whale research doesn't leave much room for a narrow job description. As technical manager, Chris is as likely to be found piloting a drone overhead as he is to be skippering the boat beneath it.
So I'll fly the drone, and it's really interesting. What we do with the drone is we try to assess its body condition. So is the whale fat? We get a photo ID, especially of the southern right whale. They have a unique pattern. They're called callosities. They're rough skin. A lot of lay people just think they're barnacles. But anyway, there's only a unique pattern, and we have the database for that for over 40 years. So we know each whale when it comes back. So we try to identify it. We get an idea of the size of the car from the drone. And once that's in, move in, and we've got to take a skin sample, skin and fat. I mean, the fat layer on a southern right whale is 30 centimeters thick, and that only takes about 40 to 50 mils. The sample is great for us. We can do so much with it. So we'll often we're actually starting to take a sample of the calf now to understand its hormone levels when it's with its mother. Obviously genetics through the skin, isotopes through the skin. But the calf, the isotope is fairly reliant on its mom. It's going to be mom's milk. But then we will also sample the mom and then note down anything interesting, any loose skin or any scars, and then we move on to the next well, and we just carry on until we're out of drone batteries, or then we carry on until we're out of biopsy tips.
Chris's wide range of skills exists for a reason. Adapting to new technology is opening windows into whale behavior that simply weren't accessible before, and with them, entirely new kinds of encounters.
I've recently become a tagger, which means we attach satellite tags onto whales, and it's incredible the data that you get from them to see that you've tagged them in Hermanus and they're ending up in the Southern Ocean, and you can tell when they've stopped traveling at speed and are now foraging around for food. It's just mind-blowing. That what I really enjoy is like all the new innovations that are coming out. Like technology is catching up amazingly fast. We've got tags that we stick on with suction cup tags that give you videos of what the whale's doing underwater and logs its whole maps it underwater. It's incredible. We can see where they're traveling throughout the world, and I'm so lucky to be able to do that. We had an amazing moment at the end of our fieldwork in 2023 on the West Coast. So the West Coast is renowned for massive aggregations of humpback whales. I'm talking hundreds, 200 whales, all feeding at once. And we had a great day. Like when there's that many whales, we finished 15 biopsy tips in the morning. We were done. We were pulling up, plankton trawls. We're doing trawls with a little net, and we're winding in the net in, trying to see what these whales are feeding on, how much they were feeding on. All of a sudden, there's just this commotion on the boat. Now, I've been pulling this net up all day. I've been driving the boat. It's like 1 o'clock in the afternoon. Last net, we're going home, and I'm dying. The net's like 50 meters under. I'm like hand pulling it up. I'm just like, whatever. I look up, and the one tourist boat is right on top of us now. I'm like, what are you doing here? Like, I'm pulling up a net, and he's like, killer whales are here. Anyway, so we had a pod of about 20 killer whales that day, and we were okay. We're like, cool, this is killer whales. That's nice. That's amazing. We got like no fin, no tips left. We used all the biopsy tips on humpbacks. We quickly cleaning them on the boat as best we can, popping the sample out, lighting them, dipping them in ethanol, lighting them on a rubber duck, quickly get them all together. Man, did we sat there for 3 hours, and we actually witnessed a killer humpback whale that day in front of our eyes. Like, it was insane. We've just written a short note paper on it. It's just been published now. It was amazing. Unbelievable. I can tell you now, the 1st of December 2023, first time I saw a killer whale kill. And since then, we've seen them pretty regularly. So if you take that in like a broad spectrum, or like a sort of broader view, the whales were exploited for many years. Their numbers were reduced hugely, obviously for human like people and oil and stuff. So what this shows is that the numbers have actually come back so much strong that they can sustain another top predator, right? And to see that in action was amazing. It was epic. I'll never forget it.
From first steps into the field to eyes in the sky, one thread runs through all of it. The work doesn't end when the sample is collected. In fact, it's only just the beginning. Because every sample bagged, every observation logged, every hour spent in impossible heat or open water, all has to go somewhere. It has to be decoded, measured, and understood. In our next episode, we leave the field behind and step into the lab, where raw samples become real answers, and where the incredible true story hidden in every clue finally begins to be told.